Hello. So, hi everyone. Welcome back to our third lecture. And this lecture we will be talking, as we have already decided in the lecture one, about the comparison between. We will be comparing our subtractive manufacturing and additive manufacturing. Now, conventionally, this topic has to be dealt in the very first lecture, but I didn't do so because even to appreciate the differences between these two methods, you should know some basics about additive manufacturing. And that was the reason why in lecture 2, I gave you a brief understanding of additive manufacturing, different stages, different steps. So now, if we discuss like what are the different points or the pointer over which the differences are drawn, a better understanding will be gained. So that's why now I have planned to keep this comparison between these two methods in the lecture 3. Now, another point is that this comparison is not to draw the advantages of like one is better than another. It is not of that sort. It is just like you need to know the possibility what can be achieved by this subtractive manufacturing and the possibilities which you can achieve by the additive manufacturing. Because if you will have both the methods in your hand, you can choose which ones suits your requirement. Choose suiting your requirement. So that's the point of this comparison. Otherwise, no such differences. Now let's start with our subtractive manufacturing. Like in subtractive manufacturing, like again we will start. We will have a block of raw material, block of material. In this block of material, we do some sort of subtraction. Okay, and then this subtraction, after subtraction, you will get a product and some waste. Now, this subtraction, if by figure, if you try to understand, then this will be your block of raw material. You will do some subtraction and then you will get some product, this product plus some waste. Now, as I have also told in previous lectures, that this subtraction will have one limit, that whatever be the dimension of this, means dimension of your product, will always be either less than or at max equal to the dimension of your raw material. Raw material. If this is your raw material. So suppose if this dimension is A, so the maximum like dimension of this what you can get will be your A. Okay, this will be the maximum. Like suppose if you carve out a sphere from this cuboid, then this will be the maximum dia. Means this dia cannot has to be smaller than or at max equal to this. So that is one limitation. Okay, now let's make it a bit extended to the next level. So our point was some raw material, some subtraction, some product plus some waste. Okay, now some points to be taken care. This subtraction can be done in two good ways. One, by either conventional, another by non-conventional. Oh, now, what do you mean by this? This meaning of this conventional is by using some machines. Using machines, you need to do this removal or subtraction from this raw material. In non-conventional, we will not be using directly machines. We mostly use some another sort of mechanisms like erosion or your chemical depletion, such sort of things, chemical reactions, such sort of things are used like in EDM or abrasive material. These are non-conventional forms, whereas in conventional you is using some sort of machines which will remove the material from a very bulk material. Okay, then even this conventional is broadly classified into two categories. These are either you can do it by using automated machines, or you can use handheld machines. Handheld handheld I say, or human operated, handheld or human operated, like you're turning, boring, such sort of things which are handheld or human operated. In automated, you can keep CNC. Okay. The second thing, these subtraction, these are the methods what you can do. It's like till now in this segment, like till from here to here, these are the methods. But this subtraction has to be done according to some plan. You cannot skip the plan. So this subtraction also has to be done using some sort of plan. So who gives you this plan? Means designer has to provide you plan. Like suppose if this is the block of material, this is the block of material, and from here you need to subtract some sort of dimensions. Means this is the sphere what you want to carve out. So all this material has to be removed, and this has to be done as per some plan, and this plan will be provided by the designer. So this designer provides plan to the manufacturer using CAD drawings. Okay, so this has to be kept in mind. Means this is a general layer. So now, what trouble people was facing, you have to understand this by conventional methods. That this is not only with conventional, but this is also true for non-conventional also. That this entire process was very repetitive. Means very iterations were to be done. Like I am writing for iteration. Means it cannot be done in one step. It has to be repeated multiple number of times. Example, that suppose your this is the initial product you wanted to start with, and you finally want to make a small cube, and then over this a small sphere like thing. Okay, so some this sort of material has to be carved out from this big raw material. So this cannot be achieved in one step or by one machine. Multiple number of machines, multiple number of machines, and multiple steps. Like even if suppose you are using your shaper machine to remove the layer by layer of this material, it has to be used multiple number of times. Then again, after achieving some sort of this bulking it out, you have to do surface finishing. Many steps or multiple steps are to be used. Then a lot of jigs and fixtures are to be used. Jigs and fixtures are to be used. So all these problems made was not like it, they didn't allow this conventional sort of manufacturing to deal with the paradigm shift. Like slowly, like there was a paradigm shift in after industrial revolution, that people started talking more of like earlier the production was the king. Like if you can produce, it's everything. But then slowly there was a paradigm shift from production to delivery, because to stay in your competitive market, this was your market necessity, market requirement. So if you want to sustain in the market, you have to deliver something on time rather than just delivering it. Like if you deliver 1000 pieces in 1 year, by the time like suppose just imagine your jeans, if you are making your jeans a shirt or trouser whatever that be, like by the time you will produce a sufficient number and push it in market, by the time your the fashion will change. So delivery was very important, and for quick delivery the time requirement has to be less. But this was not able to like that was not possible in this conventional thing, because here due to this multiple number of machines and number of iterations, your time taken was always very large. Time taken was very large. So this become a very big drawback, and then there were sufficient steps to be taken so that this paradigm shift can be taken care of. From production to delivery, the paradigm shift was the main reason which forced engineers or scientists to develop the additive manufacturing technique. So now let us talk some more disadvantages of your present subtractive manufacturing technique. So first, subtractive manufacturing. So in subtractive manufacturing, the biggest, we are talking about disadvantages. Okay, so biggest disadvantage which was that time taken was very high. Time taken was very large. Second, a lot of machines and many steps, many steps were used. Then jigs and fixtures were also a very big problem. Jigs and fixtures, like if any new product is to be manufactured, or like some sort of, you are making wheel and then you are making a screw, so the fixture or the jig what you will use in both the cases has to be very very different. So when the variety of jigs and fixtures were too high, then initial cost was very high. Initial cost of machine and setup was very high. Then this was not able to deal with, not able to deal with paradigm shift. Paradigm shift, you should know what is this paradigm shift. It is the shift from only production to delivery. Okay, so this paradigm shift was not very easily made by it. Then if you remember in previous classes, I was many a times telling you that you have like some raw material, then some subtraction, then you get product, and then some waste. Okay, this is another point. So this waste was a very big trouble. I was like telling you like this many times that our ultimate aim, or always our aim, is to change this waste to back to the raw material stage, so that your entire process be sustainable. Means if always you are keep on wasting this waste, it will not be a very good option. You can very well understand that the amount of like the waste will be very high. First of all, that's a very big thing, and you cannot discard or throw it completely, because it's the processed metal from the raw material. So already a lot of money has been invested to bring it to that state. So recycling has to be done, and that was also a very like cost input has to be done. Money was spent over there. So money is a very big thing. Now it is not so. Means even to reduce this waste, some like some lean manufacturing concepts are also there, and as lean manufacturing is also in your syllabus, I believe it will be a good thing to know it at this point, that to reduce this waste, to reduce this waste two concept of lean manufacturing, two concept of lean manufacturing came into the picture. One was SMED and another one was OTED. OTED. Now you need to know the difference. I will just talk in brief, but as this lecture is not about the lean manufacturing techniques, so I will not be in detail talking about them, about these two methods. But if you get time, please read about them. Okay. So SMED stands for single minute exchange die. Now, what do this single minute exchange time is? That they, first of all, they try to minimize the waste. Okay, they try to minimize the waste, and that is one point. And second thing is that in this they say that the exchange, like the time taken to exchange the die should not be 1 minute. You should please not confuse. This name stands for single minute, but the time taken to exchange die should be of single digit means less than or equal to 9 minutes. Please take care of that this single minute does not mean that 1 minute. It means that the time taken should be of single digit, means not 10 minute. 10 minute will be of two digit, 1 and 0, whereas 9 minute is of single digit. So that's the point in SMAT. Okay, this can be asked in some sort of objective. If not in GATE, then in some ESC or all, because GATE generally don't very much put in emphasis of such types. Otherwise, in multiple like MSQs which newly has been added, such type of questions can be added. Okay, so please take care. And it is slightly different from OTED because in this time taken to exchange, this is also called as your what it is called, changeover or startup time. Yeah, this is also called as changeover or start up time. This time taken to exchange time is also called changeover startup time. Okay, they also said, like this SMET also says, like some more concepts of modular, non-modular were also popped in. Modular and non-modular were also given by SMET only. Now, what do you mean by modular and non-modular? That suppose if you have a big machine, okay, big machine, and there is, so non-modular says that this big machine will be functional when all the parts of this machines are functional, whereas modular says that this big machine constitutes of small parts of another machine. Like this is one part, this is second part, third part, fourth part, and so on and so goes. So in case of modular, suppose if there is some problem in machine part A, then we can exchange this only machine part 1, and then entire machine will again become functional. Whereas in non-modular, all are interconnected, and if you want to change, there is no such option of changing only one part of it. In non-modular, if you want to change, then you will have to change the entire machine. So suppose if your machines are modular, then it will become very convenient or and very easy for maintenance also. So our aim is that all conventional sort of conventional subtraction, it consists subtraction, they consist of machine. So our aim will be to have these machines of modular type, so your maintenance becomes very easy. Otherwise it will become very complicated. Okay, so these were the problems which were faced. Now like one point you should take care, that this OTED, this OTED is for one touch exchange of die. It is that a changeover should happen, that changeover time should be less than 100 minutes. So here it is 100 minutes and there it was 9 minutes. Okay, means 10. If I write it equal to, then it will be 99 minutes. So you should understand this, that here this changeover time was only 9 minutes, whereas this in OTED it is 99 minutes. So that's why I have just written side by side both of this. You should not get confused. Like these are two concepts which come generally to reduce the amount of waste which is done in your yes. So these are some of the disadvantages, and you should know that this two concept of lean manufacturing, SMED and OTED, which came, that was only keeping an aim to reduce this waste amount. Okay, so these were the steps, but the most driving problem which was there, means which was the, like, out of all these problems, the most important problem which this subtractive manufacturing was facing was this thing, the paradigm shift from production to delivery. This was the biggest driving force which made all the engineers and scientists to, like, out of all this, this was the most important, which forced every scientist and engineers to develop a method in which this production to delivery, means this delivery time has to be reduced. And then there were some corrections which were done, and then the genesis of additive manufacturing came in. Okay, so now how those people start thinking about, like, developing this method, I will just tell. First, what they did, they thought that we all start, like, how to reduce time. Main aim in their mind was to reduce the delivery time. So to do this, first what they did, they started talking about making a digital database. Now, what is your digital database? The digital database keeps two things. One, it is a collection of your CAD models, and another, it keeps a library of process plans, process plans. These are the two things which this digital database will have, and you will understand how it will help people. Okay, so what are these CAD models? These are the plans, like plans earlier based on which subtractive manufacturing was done. So this CAD model, if you will keep a database where all the CAD models of design, whatever are being manufactured, are kept and stored for ready reference, you can very well understand that suppose if you want to make any modification to pre-existing design, it will become very easy. You will already have one CAD model to start from, and from that CAD model, you can make some suitable adjustment or modifications to reach your desired product. So any sort of modifications were very easy. Then second, you were already having one, means initial start point. Suppose if you want to make one screw which is different from already pre-existing screw, so you will have only one dimension to change and you will get your design model. Okay, then this process plan or this library of process plan, what was this containing? This was having a machine list of machines which were used, then list of machine layout, list of machine layouts, then all the process plan for each machine. Means I will just tell you what are these process plan for each machine. Suppose you read in this list of machines, suppose to make a component, whether you need one milling machine or two milling machine, one shaper, drilling. So all the list of machines you can have. Then if you are already pre-existing machine list is there, then you can plan as per it, that after machining or in this, after doing turning for a couple, like so much time will take, and after turning it will be shifted to a drill machine where a through and through hole will be made. So such list of machines, you can know whether all the machines are working right or not. So it was very convenient. Then that is called list of machine layouts, like where those machines are, how these machines are laid out in shop floor, those all were there. Then process plan for each manufacturing means what to do, when to do, like all those things were mentioned. Then quality checks means what are quality checks, at which steps you need to do, those things were also mentioned in this. Then like inventory control was very easy. Inventory control was quite easy. Okay, so with all these things, like your after having a digital database, this was became very helpful to your very helpful to your all the peoples. Okay, like it helped manufacturing people, it helped your designer. Okay, it helped your quality engineers, it also helped your salespeople, because you can understand this manufacturing people, because they were already having list of machine layout, etc. Designers, they already had an initial start point to start from because the pre-existing CAD models. Quality engineers, they know which all quality checks to be done and when to be done. Salespeople, they can very well understand when your product will come out of manufacturing, and then they can deliver it, so as per that they can do suitable modification. So with all these modifications, first step, which was the digital database, was made. Means it was having so much advantage, then this digital data was made. Once this digital data was made, then people realized that they can make some manufacturing method which can directly eliminate these machines, and then they came up with the idea of additive manufacturing. And as in previous lecture already, the steps I have told you what are the steps in additive manufacturing, you can very well understand that they only need, in additive manufacturing, they only need some initial raw material, and with this raw material, with this CAD model as the input, in between there is one STL format conversion. These CAD models after STL modification was given to the additive manufacturing machine, and then you will directly get the product, and it will reduce all these steps. This time taken in all these things were eliminated. So by this way, additive manufacturing came into picture. Now, let's talk about the advantages what we get by using additive manufacturing. So first advantages. Now, till now what I have told you, I have just discussed the disadvantages of subtractive manufacturing, and then how engineers and scientists came up by trying to eliminate some of the steps. After making digital database, they realized that there are few steps which they can skip, and then they can make a manufacturing method which will be very fast. So now let us talk about the advantages of additive manufacturing. Number one, suppose if when you will have your digital database, so from digital database to make the product, this entire process will become very seamless. Means once you will have digital database, which will be your CAD models, you just have to make slicing of this in STL format, send it to machine, and then you will directly get product with very minimum waste. This was one very big advantage of additive manufacturing. Second one, very less number of machine. So your maintenance cost came down. Then third one, which is that raw material to start from, it will be common, which you will understand slowly, that to make any sort of product, suppose if you want to make some product of titanium, then if you have titanium powder, so means if titanium powder, you start doing 3D manufacturing with this titanium powder, so any sort of material, like whatever be the shape this product will have, that will not be a problem at all. Whether that be sheet, whether that be a block, whether that be any sort of component, it will be very easy. So this give an freedom from the sort of raw material to start from. So this was also a very big flexibility which it provided. So it became a very flexible manufacturing method. Okay. Then another now very important thing, important advantage is, I'm just deleting it now. If you need, you can come back always. So another advantage was there was no problem of tooling. Means tooling was not a problem. Now, what is this meaning of tooling? That suppose if on a raw material you want to make a elliptical hole. Okay, this is a sheet or some raw material and you want to make one elliptical hole. Then in subtractive manufacturing, do you think you have any tool of elliptical this shape? No, you cannot have. So what you will do, I will just make a view from here. This is some elliptical hole like this. So what you will do, you will design a path of tool. Your tool will have suppose this big dia. So you will design the path, travel path in such a way that you get a hole of this sort. Understood? This is the elliptical hole you wanted to make with a tool which is of this sort, having a means some sort of milling tool. Suppose it is having some flanges, some cutting end. So you want to cut elliptical hole. So just by designing the path, means by designing the tool path, tool path, tool path modification, you can achieve any sort of shape, the shape which is not very similar to tool. See, shape not similar to this tool. Okay, so this tooling was not a problem in your additive subtractive manufacturing. To make like this tooling problem is like sorted out by tool path modification. Subtractive manufacturing, this problem of tooling was generally tackled by making modifications in tool path, whereas in additive manufacturing this tooling will have no such problem. Means if you want to make a elliptical hole or you want to make any channel, so such type of things will not be a problem at all. So suppose if you want to make any micro channels, then your subtractive manufacturing will not be a very good option, but your additive manufacturing will give you very nice micro channels made. That's why I might have shown you this in the very first lecture, that suppose if you want to make a drill hole straight, then subtractive manufacturing is very good. But if you want to make a hole or a channel which is like this, a shape is inside like a snake and coming out here, then for this subtractive additive manufacturing is very good, whereas by subtractive manufacturing it will not at all be possible. So tooling of making any sort of hole is not a problem in additive manufacturing. Tooling was not a problem in additive manufacturing. Okay, I hope you understood this one. Second thing, in this mass customization, a easy point first I will tell you, which was that no need of jigs and fixture. No need of jigs and fixtures. You can very well understand that you are making layer by layer manufacturing, so such jigs to hold a job will not be necessary. Then now next point, mass customization. Mass customization was very easy. Now this point is very important. Now mass customization, what do you mean by now by mass customization, and how it is very different? You should keep this in mind, different from mass production. Please keep this in mind. Mass production, suppose if you want to make one screw, the same screw, like 10,000 pieces, then your subtractive manufacturing is a very good method. But if you want to make a screw, one piece screw of this shape, then in this case additive manufacturing will be a very quick and efficient method. So this is called mass customization. When you want something suiting a specific requirement, then you do customization. And if this customization works out, then you can make thousands of such pieces by subtractive manufacturing. Okay, because setup charge in subtractive manufacturing is very high. So suppose until unless you don't require some very bulk amount of order or any customized object, it will not at all a feasible method to use your additive manufacturing thing. But if you want something to have a very unique shape or contour or some very specific requirements, then additive manufacturing is a very good method. Now you might think that, sir, once if suppose we get a model, we can always make a mass production of it. Yes, you are correct. Sometimes we can do that, but most of the time we cannot do it. And I will give you one example where customization is the very important thing. And that's the reason why additive manufacturing flourished. I will delete this. So suppose I have example. Yes, now see this. Now this is a fracture which happened to this person. And this fracture was of always, whenever if a fracture will happen to any person, you cannot expect that the fracture of two person will have of same nature, okay, and at same location. So if there is a fracture of such sort, then you will have to customize it, and for this customization it will always be unique. So customization is necessary. Okay, and every time this will change. With this, any fracture which will human will have, whether that be in his head, whether that be in his leg, so every part will have a different sort of fracture, and to cater to a specific sort of fracture, you will have a customization which is needed. And by 3D printing, you can make such type of object which can be implanted in human to suit a particular patch or to heal a particular patch of him. Okay, so this customization is very necessary, and then additive manufacturing is a very good method in it. If you want to do something, then additive manufacturing is one of the best method for customization. Now you cannot make mass production of this. It is not at all needed, because if another person will have fracture, it will be of different nature. So you cannot make this into 1,000 pieces and keep as a as a store in your storage. You cannot maintain an inventory of it. You will have to customize it when and how it is needed. So customization is important. Now, second, another point is your weight reduction. Weight reduction. Now, this weight reduction, there was one study. I will just show you. This was a case study which was done by your, yes, by the saving project. Now suppose if you are making a buckle of this sort. This is the same buckle what is there in your belt also. So a conventional steel buckle will weight around 155 grams. If you are making it of steel, then this is your minimum thing what you can expect. But if you make it of titanium of some modified dimension, like you can see there are some holes and some ridges. So those design modifications are for strength. Whereas making this by your subtractive manufacturing is very difficult. Whereas by additive manufacturing, very easily you can make it. So this will have a weight which will be 55% less than this. So over a period of time, suppose if this buckle is changed in your Airbus 380, which is having an economic seating of 853 seats, so it will overall reduce 72.5 kg, and this much kg of reduction in weight you can always compare over a period of the lifespan of your Airbus, and fuel or amount of money which will be saved in its fuel can be calculated, and this was done by your one of the project people. Okay, so this was by Plunkett Associates. Similarly, this 120 gram, if you are not using titanium, you are using aluminum, then this 120 grams will be the, still some reduction will be there, some 35 grams reduction will be there. Again, some calculations you can make, and you can see how a small design modifications of reducing weight, you can get a lot of advantages. Okay, then another advantage is your green manufacturing. Green manufacturing means green manufacturing means the waste is first very less, and amount of carbon footprint in of carbon footprint of additive manufacturing is also quite less. And this is not because of manufacturing phase, but the phase where your raw material, product plus waste. So this conversion of waste to raw material, in this conversion, a lot of carbon dioxide is released, but in subtractive manufacturing, as this is very less, so this step becomes very less, CO2 productions become very less, and it becomes very, environmental friendly also. Then, a very important thing which drives all the thing is your cost. Now, don't think that this additive manufacturing, it's a warning I'm giving you, that if by seeing all these advantages, if someone will ask you which is cheaper, additive manufacturing or subtractive manufacturing, which is cheaper, then don't blindly say additive manufacturing. It's not so. Additive manufacturing is cheaper only when your complexities are high. Cheaper when complexity are higher, and second, there are some customization. Cheaper only when these 2 points are there. Otherwise, your subtractive manufacturing is always cheaper. In this, the cost is while setting up the to set up the facility, you have to spend some money. Otherwise, if there is a design and there is a like you have already made everything very high, like sequential and very organized, then subtractive manufacturing will be a very good option, very very economical method for such cases. So there is a curve also which you will see in many books and many resources. That curve is called cost comparison with complexity. I will just draw it for you so you can have an idea. So in this cost comparison curve, you can see that this is the cost and this is the way the complexity increases. Like if your complexity increases and this is the cost, how the curve goes, it will keep on increasing. The cost will keep on increasing as the complexity increases. In additive manufacturing, there is always a preset of money which you will always spend. This is because you have to uh, purchase the raw material, you have to purchase the machine, so those things are additional, this much head or this much extra money you already have to invest. But after a point, even if the complexity increases, the cost of additive manufacturing will be constant. This is the cost of additive manufacturing, which just stays already like whatever be the complexity, your cost of this additive manufacturing will be constant. Cost of additive manufacturing is constant. Like if once you have the raw material and machines, whatever be the complexity, it has nothing to do with it, the cost will be constant. Whereas in subtractive manufacturing, the costs keep on increasing. You can see very well see how the cost is increasing. So this is called, so suppose if you have an object which has too much of complexity, you can see that this much money which you will spend in subtractive manufacturing, you will not have to spend it in case of additive manufacturing. So that's why it is called complexity for free. So this cost comparison between subtractive manufacturing and additive manufacturing has to be taken with pinch of salt. If it is highly complex, then additive manufacturing is a very good method. If it is not so, if it is in somewhere in this zone, means complexity is less, then here your subtractive manufacturing will be a better option. Okay. Next point. Next point is a very important point, that by using additive manufacturing, you can achieve something called as FGMS. This FGMS stands for functionally graded materials, not S, FGMs, graded materials. Now, what do you mean by functionally graded materials? It means having an object which will have different properties at different parts. It means different properties at different parts, different location in same part. I will give you an example. Suppose you have a metal base. Okay, this is your metal base, and on this metal base somehow you can make some you can attach some soft parts, some very form like thing, and then entire this on wood you fasten it using some screws. So what you will get, this is wood, this is metal, and this is some like porous type of thing, porous material, something other than that. Then this such type of combinations can be possible while making with 3D printing. Like wood, you don't need to worry, you cannot manufacture it, but it is just being fastened, so there is no trouble. For a while you can use some metal powders to make this base, and then you can change your material, you can use different material to make this part of it. So you will get one single big part which will have different properties. This will have another one property, metal will have second property, wood will have third property. So you can see in the very same component, you can have a final product which will have different properties. Now you may wonder where such type of things can be used. So suppose if you are putting, like, there is a bottle, glass bottle. So very well you can, this is the opening, this side is the opening. So you can just insert this under the glass bottle, and you can clean this wall of glass bottle using such type of things. Okay, so such sort of products can be made. Another very good example of functionally graded material are human bones. Human bones. Human bones, due to different like percentage of calcium at different levels, your bone is hollow from inside. That is one point. Second thing, it is having different percentage of calcium in different types of bone, like your femur bone, the biggest bone in your body. It cannot be too rigid, otherwise there will be no elasticity, and it cannot be very elastic because it has to take up your load. So bones are having different properties at different thickness, like different levels. So such human bones can be very easily be manufactured by additive manufacturing. Suppose you get a fracture in your thigh, then you can expect some person can change it using some product or similar femur bone made up of titanium or some other by additive manufacturing. Okay, so these are the some of the advantages of your additive manufacturing. But you should also know what are the disadvantages of additive manufacturing. Like, till now you have seen already many advantages, so it doesn't mean that you can use additive manufacturing all the places. There are some disadvantages and you should know them. First one is, there are some very unexpected pre and post processing. Means, and means many, this is one of them. Second, lack of standards. Now, the standards and all you might not understand at this point of time, but suppose if you are making a product, then it has to follow some sort of standard to get a product which is reliable. So such sort of standards are not very much well developed. Like suppose if you do some sort of non-destructive analysis of a 3D printed, you will get some sort of defects. But to identify those defects, you need to have a database from where you can compare and tell that this is some sort of, this is a crack or this is some sort of defect which is already mentioned in the standard. So such standards are still yet to come. There are few, but it's not as exhaustive as your subtractive manufacturing. Then third one, already I have told you, it has a very high process cost, but cost of complexity is less. Okay, so mass production mass production, not possible. Not possible or not economical, I should say. Second one, that high process cost. I'll write this only. High process cost for simple objects, whereas less cost for complex objects. Okay, then the material whatever are made by these like additive manufacturing, strength is less, strength is low of additive manufacturing products. And this is because complete fusion is not happening, which is happening in your like this is some sort of layer by layer manufacturing. And in such layer by layer manufacturing, that fusion is not happening between two layers. So most of the times the strength what you will achieve will not be as good as your subtractive manufacturing thing. Now at last we will talk about some advantages of subtractive manufacturing. First one, it is very good for assembly work. Good for assembly work. So suppose if you want to make an assembly which constitutes of many small parts, many parts, part 1, part 2, part n. So all these are to be made together, attached together to make one big assembly. If there is some such assembly work is going on, then to make small parts, it's always better to go for subtractive manufacturing. Here, additive manufacturing will not be a very good option. Second, standards are present. Too many standards are present because it is there existing for very long. So many standards people have developed over the period of time. Now, third advantage, which is very important, and I should mention it now, a very important advantage. Wall thickness less than tool size is possible. What do this mean? This is a very important advantage. Suppose now in lecture 2, I have told you how additive manufacturing is done, and you have seen that it is formed by layer. Now let us suppose I want to make a container of this sort. Okay, so this container will have some thickness. So some thickness is here. Now what can be the minimum thickness what you can achieve by using additive manufacturing? You will have one nozzle. This is your nozzle through which material will come out and it will keep on depositing. So suppose your this material is coming out. This is the material. So if suppose your nozzle size is D, then the minimum wall thickness what you can get is D only. Is this, it will form like this, one layer, then second layer. So this wall thickness is dependent on this D. Means whatever be the nozzle size, that is the minimum nozzle size. Understood? Means this wall thickness cannot be less than this D. Whereas such sort of limitations are not there in your subtractive manufacturing. If you want D, it's okay. If you want D by 2, that is also okay, because while cutting something, if you have a tool, then you can cut whatever, how many layers you want, you can cut, and then you can get a final thickness of your desired dimension. Okay, and one similar, like because of this, one very similar advantage is also there, that accuracy and tolerance. So what you can get what you can get by by subtractive manufacturing is very high. Accuracy and tolerances what you can get by subtractive manufacturing is very high, and I will make you some comparison between them. I will put you some options, like some datas which you can remember what they say. Like suppose you are like suppose let me make a table. Suppose if there are some methods, then what sort of tolerance you can get, and what is the minimum layer thickness. These are some numerical value which you can remember. Suppose you are using CNC. Now CNC is a method of subtractive manufacturing. So in CNC, the tolerance what you can achieve is 0.025 to 0.125, and cutting depth of minimum 0.01 mm can also be achieved. Then suppose SLS method, now like additive manufacturing here, let's take SLS. In SLS, the minimum tolerance what you can get is point plus minus 0.03 mm, and this layer thickness can vary from zero point 0.7 to 1 mm. If you there are some industrial FDM, then minimum thickness is 0.5 mm plus minus 0.5 mm, and the layer thickness go from zero point 0.8 to 1 mm. And if you are using DMLS, which stands for direct metal laser sintering, so in DMLS it can go till point plus minus zero point 0.1, and minimum layer thickness is 0.4 mm. Now don't worry about what is FDM, what is SLS, all these things we will see in next classes, but you should know that whatever be the method, these are the some of the minimum tolerance, like what is the minimum tolerance or minimum layer thickness what you can achieve by your subtractive manufacturing and additive manufacturing. You can see in all this also that this, the tolerance and the minimum thickness what you can achieve in subtractive manufacturing is far better than any of the additive manufacturing methods. So these are the advantages of your subtractive manufacturing over additive manufacturing. So my lecture by just see what all we discussed today. So today our plan was to your compare your subtractive manufacturing and additive manufacturing. So first I laid out the disadvantages of subtractive manufacturing, then how this, like how one digital database was made. This digital database gave an idea to other scientists. It gave the necessary steps. What can be steps which were eliminated or are to be eliminated. So it gave an idea. By this additive manufacturing was method came into picture. Like this is called genesis of additive manufacturing. Then I discussed about advantages of additive manufacturing, then disadvantages of additive manufacturing, and then even if there are some disadvantages, these disadvantages can be covered up by the advantages of subtractive manufacturing. Here first disadvantage, here there's some advantages of subtractive manufacturing, and then we concluded the entire lecture. So with this you can understand, it will give you an idea when to choose what, when to use such advantages of additive manufacturing and when to use advantages of subtractive manufacturing. So now with this entire picture in your mind, you can make a very smart and economical decision when to choose subtractive and when to choose additive manufacturing and then make product. In the next lectures, we will talk about different methods of different methods of your different sort of additive manufacturing, different type of additive manufacturing. Like if I say SLS, if I say industrial FDM, DMLS, what do you mean by them? Stereolithography. One by one we will see it. Okay, thank you. Thank you for giving me your time. Katil Kabuto signing off. Please like, share, subscribe so I can further make few more videos. Thank you. Jai Hind.